Welcome to Scanner School session number 15. We are continuing our conversation about P25, and today we're going into P25 Phase 1, X2-TDMA, and Phase 2 trunking.
Welcome to the Scanner School, a podcast dedicated to the scanner radio hobby. Class is about to begin. Here is your host, Phil Lichtenberger.
So welcome back to Scanner School. We teach you everything that you need to know about the scanner radio hobby. My name is Phil Lichtenberger. My amateur radio call sign is W2LIE, and you are listening to the Scanner School podcast. This is session number 15, and you can go online to scannerschool.com/session15 and look at all the show notes or even download another copy of the Scanner School podcast if you happen to be listening from a pod type of device or your smartphone or something like that. If you've missed last week's session, in session number 14, we kind of went through the fundamentals and the building blocks of a P25 system. We're going to cover a little bit of that this week, but if you want to go back, if you didn't listen to last week's episode, I would recommend going back to session 14. And again, you can do that by going to scannerschool.com/session14. And you'll be able to pick up on some of the basics of P25 systems. But we're going to touch on just a little bit of that this week, and we're going to start right from the top where we kind of started with session 14 about what is a P25 system. So, again, quoting from Wikipedia and the Daniels P25 guide. And again, this is for the benefit of those who didn't listen to last week's session. Project 25, or P25, is a set of standards produced through the joint efforts of the Association of Public Safety Communications Officials International, the National Association of the State Telecommunications Directors, selected federal agencies, and the National Communications System, and standardized under the Telecommunications Industry Association. The P25 suite of standards involves digital land mobile radio services for local, state, and national public safety organizations and agencies. Again, this is the definition from Wikipedia, which I believe was lifted from the Daniels P25 guide, which is now owned by Codan Radio. Okay, so with that out of the way, we now know that P25 is a set of standards, right? Which means that you can have multiple different manufacturers of radios on the same system. There's building blocks. Each can be from its own manufacturer, so you're not locked in to say if you buy a Motorola system, the entire network has to be Motorola, or if it's an E.F. Johnson system or Harris. That's not the way that P25 was built to work. It was built so that you can take like a Zetron console and a Harris this and a Motorola that and use E.F. Johnson radios out in the field if you wanted to go that route. They were all supposed to be able to be interoperable between all the pieces of equipment. So with that said, if you're using something that's specific to a particular manufacturer, like a proprietary type of technology or solution, and we're going to get into that in a second here, that is something that is outside of the standard, and yes, that would lock you into that manufacturer for whatever it is that you are looking to use. So there's also a couple of things that we need to remember here about P25. Now again, this is a digital network. Everything on here is packet based. It's not an analog. It's not voice in the sense that you and I listen and hear voice. It's all digital. And that's what makes P25 different than the older systems. And that's also what makes P25 cost a little bit more money when you're looking at buying a scanner radio. So there are a couple of codecs or voice encoders and decoders that are used, and they are licensed by the Digital Voice Systems, Inc., which is abbreviated by DVSI, or Delta Victor Sierra India. And they own the rights to IMBE, which is improved multiband excitation, and AMBE plus 2, which is the advanced multiband excitation as well. When a scanner manufacturer creates the hardware, and puts that chip in there, they have to license it. And who in the end ends up paying for the license? You and I, when we go out and we buy a radio to use. Let's start a little bit at the beginning here when it comes to programming P25 into your scanner. So let's talk about the simplest way, which is a conventional P25, and we'll build upon from here. So in session 14, again, scannerschool.com/session 14, we talked about conventional P25. And in session 3, we talked about PL, DPL, and NAC. So in conventional P25, we use network access codes, or NACs, to either filter ourselves on the system or get onto the system, right? It's basically the P25 equivalent of PL and DPL. So a NAC is a 3-digit hexadecimal number. It's a 12-byte string that goes over the air before the voice packets begin. There's 4,096 possible NACs that can be used. And there's 3 special NACs out of all of those. $293 is the default NAC when you're programming in something into the radio for the first time. There's $F7E, which is Foxtrot 7 Echo, and that's basically a CSQ, whereas any NAC, no matter what it is, if it's received, if your receiver is set to that NAC, your receiver is going to open the squelch for it. And if you were building a repeater system, F7F, which is Foxtrot 7 Foxtrot, if a repeater receives any NAC, it will go out over that. But again, as a scanner listener, if you want it to be in CSQ mode and you want to pick up every single transmission that's P25, just don't set it. Leave it blank, and your scanner will go into a search mode. So let's talk about P25 trunking. There's 3 things we have to worry about here. Phase 1, Phase 2, and X2-TDMA. Before we get into that, let's really talk about when you set up your scanner. Obviously, you're going to do kind of the same methods that you would be using for an EDAX or Motorola or LTR, right? On Uniden World, you're going to need to create the systems and then the sites, and inside the sites, you're going to put all your frequencies in. On the Whistler, the GRE, and the Radio Shack line, again, you're going to build a site within a system with all the frequencies in there as well. So one of the things, if you're looking at a P25 system online, say like on the Radio Reference Database, you may see a couple of acronyms on there that you're really not sure what they are. The first one being WACN, or Whiskey Alpha Charlie November, which is Wide Area Communications Network. This WACN, which I hope I'm pronouncing correctly, identifies the entire network. You also had a system ID, which identifies the system. So the system and the WACN together identify the entire system itself. And within that, you have multiple sites, and each site can have an ID as well. So just like Motorola Type 2, you can go ahead and just program in the control channels or the alternative control channels on a P25 system. There is no need, though, however, to put in a band plan or any of the voice channels, because what ends up happening with a P25 system is part of the protocol over the air. It identifies all of the information that needs to be out there for an end user to get onto the system as part of the interoperability part of the network. So what happens is you'll get the WACN, the system ID, the protocol it's using, if it's using phase 1 or phase 2, you'll get the band plan on there. Will all kind of go out over the air so that if a roaming radio needs to get onto the system, it's able to do so. At least that's the way that I understand it. So let's talk about phase 1. So phase 1 is basically like using the entire frequency the way we consider it when dealing with the analog world, right? One transmission hogs the frequency for the entire time that it's transmitting, and then when you let go of the PTT, when the user drops the carrier, the frequency is then idle. And that's the way that phase 1 works. It's basically when you transmit, you're tying up the entire 12.5 kilohertz bandwidth of that frequency, and it uses FDMA access, which is Foxtrot, Delta, Michael, Alpha. Now, FDMA is frequency division multiple access. And really what that just means is what we just spoke about. You're tying up the frequency for the full time that you're transmitting. End of story. Phase 1, one user at a time on a frequency. Now, if you want to start getting really technical, what ends up happening is it uses C4 FM, which is continuous 4-level FM. And again, the acronym being Charlie number 4, Foxtrot, Michael. It's basically 4 symbols that are transmitted. And the way that these symbols are transmitted is done so by changing the actual frequency. And when the frequency changes, it indicates there's a new symbol. I know it's a little bit difficult, but for those of you who kind of understand how this works, maybe you can explain it better than I can. It's really difficult to try and describe this, at least for me, verbally. So what I will do is I'll look around and see if I can find some public domain pictures of this, and I will add it into the show notes for this podcast so you can kind of get a visualization of not only what C4 FM looks like, but also what CQ-PSK, and we'll get to CQ-PSK in a second. So basically what you need to know about C4 FM is that it's a way of transmitting symbols over the air. So the symbol rate is transmitted in what we call symbols per second. And in C4 FM, it's 4,800 symbols per second. And in terminology that most of us are familiar with, that equates to 9,600 bits per second. So what happens is you have strings of data that go out, right? You have a header, you have the voice packets, you have error correction in there as well, our CRC values. So what happens within that 9,600 bits per second? 4,400 bits are reserved for voice, 2,800 bits are reserved for data, and 2,400 bits are reserved for signaling and control. And that equals your 94 bits. That equals your 9,600 bits per second. And that's what goes out over a 12.5 kilohertz wide frequency when you're listening to a phase 1 system. Now, receivers can also support a CQ-PSK, that's Charlie, Quebec, Papa, Sierra, Kilo, and that stands for Quadrature Phase Shift Keying. Now, this is an improvement over the C4 FM, and the bandwidth is half of that of C4 FM, or only about 6 kilohertz. Now, remember this. Phase 1 is 12.5. That's narrowband FM. So remember, we talked about narrowband on session 5 of the Scanner School podcast. Again, scannerschool.com/session5. Narrowband was 12.5 kilohertz wide. The new narrowband was 6.25 kilohertz wide, right? It's half of 12.5. So remember this. C4 FM was 12.5 kilohertz. The new the new modulation scheme of CQ-PSK fits in 6 kilohertz wide. Keep that in mind. So for phase 1, we use the IMBE vocoder. It's 12.5 kilohertz wide. And when you use that frequency to transmit, you use the entire frequency. So phase 2 changes things up just a little bit. We go now and we use TDMA technology, or time division multiple access. And really what that means is you've taken that single frequency and you've split it in 2 by shifting in time who gets to use that frequency. So really quick, what happens here is that you get user A and then user B, then user A, then user B, and user A and user B. And they alternate who gets to use that frequency resource. And you're basically going back and forth in time as to who uses it. Okay. And it happens so fast that we as humans don't know what's happening. So it sounds like it's a full transmission the entire time, but it's really happening so fast that it's being cut in half. Okay. Now, Phase 2 is required on all new 700 megahertz P25 systems. So if anything new out there is being built in your area and it's 700 megahertz, it's going to be Phase 2. Now, Phase 2 also uses the AMBE plus 2 vocoder, which reduces your bit rate. And don't forget, we talked earlier, it also uses CQ-PSK, which is 6 kilohertz wide, half of that of Phase 1. So you can see there's a lot of extra stuff going on here that compresses the amount of bits required for a Phase 2 transmission. So let's talk about the advantages of Phase 2 over Phase 1. Well, because we're splitting the frequency in half over time, you can get twice the number of users in the same number of voice channels. Now, this also helps the people licensing and maintaining the network because now they only need half the number of resources. They don't need a larger pool of frequencies. It's more efficient in the spectrum. Also, in theory, radios are keying up now for half the amount of time, so they are saving on battery, and the battery should, again, in theory, last longer. I'm not saying the battery's going to last twice as long, but it should, in theory, last longer because you're not keying up for the same length of time. So now we've talked about Phase 1, Phase 2, and we had talked at the beginning about proprietary solutions and how with a Phase 1 and Phase 2, it's part of the open P25 standard. Well, Motorola was looking for a solution after Phase 1, and there really wasn't one developed yet, and Motorola came out with X2-TDMA. It's proprietary to Motorola, which means that only Motorola can use it, and that's, from what I have been reading, that's the way it's set up. Now, please, somebody, if I'm wrong, please correct me. But it's a gateway. It's not Phase 2. It's a different animal from Phase 2. But it's using TDMA, and I believe it uses the entire 9600 baud, or 9600 bits per second. And again, only Motorola's equipment would work on an X2 TDMA system. So here we go. We've now talked about Phase 1, Phase 2, conventional, X2 TDMA. What does that mean for your scanner? Well, if you had a scanner that was a trunk tracker type 3 that allowed you to do LTR, Motorola, and EDAX. Well, now you add P25 on top of it, and you've got a type 4 scanner. You want to add on Phase 2? Welcome to type 5. All right, trunk tracker 5 is where we're at now. So let's talk a little bit about how to improve your P25 reception. Now, a lot of the problem that scanners have is simulcast issues, whereas if you receive multiple, in a simulcast setup, right, you have multiple towers simulcasting the same transmission over the same frequency, and that can cause a problem due to timing delay on scanners. One of the things that you can do is get off of an outdoor antenna and bring your antenna inside. This way you're only on one site. Or you can get a Yagi antenna and point it away from another site. You can add the attenuator onto your scanner, would kind of do the same thing as well. Now, if that is not your problem, sometimes what happens is there's settings inside the scanner that adjust the P25 threshold. So if you have a good decode rate on your scanner, and again, this won't fix anything that's a bad receive rate, but this will help to improve your decode rate, which should make it sound better to you. And there's 3 settings on a Uniden scanner, and this is called the P25 threshold. There's a low, a medium, and a high. And the scanner can be set up for an automatic, where it hunts down the best values by sampling the transmission every time it keys up. So as the transmission stays on longer, it will eventually settle in something that works fine. But every time the transmission keys up again, it starts all over again at the default value and has to single down or has to work its way into a good value. There's default, which means it stays at whatever the default value is and never moves around and tries to figure it out. And then there's manual, where you go in there and you tell the scanner, this is the best value to use on this site, not system, site. This is a site-specific threshold. So here we go. What this means is it's a way of fine-tuning the voltages that are required to get a good signal. So as you change the threshold, you are kind of, say, opening and tightening the squelch if this was an analog system. All right, is a way to think about it. And you are kind of, as you go down the scale, you are raising the lower limit and you are lowering the higher limit, bringing your window or your filter closer together. As you go higher in the numbers, you are widening your filter, making the threshold value larger. So what you really want is you want to try and find a value that works best for your radio. And the simplest way to do that is to look at the error code that's on your display as you are going through the manual settings on the scanner. Okay. Now, the best way to figure out how to do this for your particular scanner, again, if you're using the Uniden, is check out Mark's Scanners. And you can go there really quickly by going to scannerschool.com/marksscanners, and we'll redirect you to his website automatically. We'll also put a link in the show notes to Mark's Scanners. He did a really great write-up on how to do this. Now, if you are using Whistler and GRE or Radio Shack, it's a little bit more cumbersome to do so. And there's 3 settings that need to be set independently of each other. First, you need to start with your ADC. This is your analog to digital converter. Think of this as a signal coming into your scanner, and you want to adjust the gain on this so that you're not oversaturating the codec on the scanner. Think about when you have your volume set too loud on a cheap pair of speakers and you start getting vibrations and you can't understand anything because it's too mumbled. That is what happens when you overdrive the ADC. So you want to bring that level down as far as you can in order to still get a good signal. Then the next thing you want to do is you want to set your DAC or your digital to analog converter. Same story applies here. You want to adjust that, and that's the output of the codec. Third, you want to set up your DSP or your digital signal processor. Now, this is the actual brain behind taking that digital signal and processing it so that it can be heard out the speaker of your scanner. And it's a speed. So the more processing power you take on it, the slower it will be to come out of the scanner. Now, this really isn't a problem unless you have multiple radios laying around and you may get that echoing effect going on, where one scanner may be slightly delayed from another because the digital signal processor is working harder or longer in the other scanner. If you lower that value, you may find out that you can decrease that echo, and that would be a way of getting rid of that if you have 2 scanners listening to the same thing side by side. So there we go. The last 2 sessions, session 14 and 15, we discussed P25. I know this was a topic that a lot of you were looking forward to, and I hope that I did a good enough job in explaining it to you without getting anybody too lost in the woods. It's a tough one. I understand that. So if you're still lost on P25, I invite you to join me on my Facebook Live group, which for right now will be held every Saturday at 11 a.m. Eastern U.S. time on our Facebook page. To get there, go to scannerschool.com/Facebook, and it will be on that page. We'll also have an event set up in Facebook so you can RSVP on there and be reminded before we go live on our sessions. So the Scanner School podcast is sponsored by EastCoastPagers.com. And if you've been listening to the podcast over the last several weeks or since the beginning, you've been hearing this read through and through for the last couple of sessions. Well, who exactly owns East Coast Pagers? Well, that's me. I own East Coast Pagers. I've started. It was a spinoff of Monitor Long Island Inc., which is my S Corp, which now owns all my web businesses and web properties, including East Coast Pagers and the Scanner School podcast, which is why I am able to offer a little bonus to anybody who uses the special URL or special web link to order a Unication G1, G4, G5, or the S-Quad Voice, or the brand new S-Quad 360 pager by Swissphone. And in order to receive that bonus, all you have to do is go to eastcoastpagers.com/Scanner School. So I want to thank you very much for joining us again for the Scanner School podcast. So please let me know how I did. Did I explain P25 well enough, or did I leave things out, or was I too technical? I would love to hear your feedback. Please leave your feedback at the website in the show notes. You can do so at the bottom by leaving a comment. You can also subscribe to the podcast on iTunes. And don't forget to join us on our Facebook Live, where we will answer your Q&A live via Facebook. So again, thank you so much for joining the Scanner School podcast, where we teach you everything that you need to know about the scanner radio hobby. We'll see you next week on session 16, where we review a couple of P25 scanners, and I'll give you my recommendations as to the scanner or scanners that I would choose if I was in the market for another scanner, which of course I always am. 73, everyone.
Thanks for listening to the Scanner School podcast. Be sure to visit www.scannerschool.com to access the show notes and bonus content.